Thank you very much, Lindsay, for that introduction. That was a really good review and really good. And yeah, great pleasure to talk to you this afternoon about Daphne and talk about how Daphne might support your research. Okay, so I'm going to give as I said, I'm going to give an introduction to what Daphne is, what we're trying to do, and how it might get used, or the offer might get used. And then we'll pass on to some demonstrations going a bit more depth with some of the Daphne team, as mentioned, on how it works in practice. So I hope you can all see that. That's my introductory slide. Yeah, so I'm going to give, yeah, without further ado, an introduction to Daphne. So yeah, so why Daphne? So why are we doing this? As you know, why are we building Daphne in the first place? Okay, so what we're interested is in supporting modeling for the whole of the built environment. So built environment is composed of sort of three. I stole this image shamelessly from CDVB in Cambridge because it really expresses very well what we're trying to do here. So the built environment is a really complex system with combining sort of economic infrastructure, so transport systems, energy systems, waste systems, water systems, those sorts of economic components that we have in our built environment, with the social infrastructure, so where people live, where people work, what people do, health systems, leisure systems, all the other sorts of things we do, and also combining it, the complexities of the natural environment. So information about the land use, about weather, about biodiversity, about green spaces and the rest of it. And we want to combine all those things together into models of the built environment so we can go through the stages of the operation of that built environment, from planning, scenario analysis in the future, building and designing and building effective building infrastructure into the future, how we then operate and run that infrastructure effectively, and then evolve it. How do we decommission it? How do we change it? How do we alter it the best ways in the future? And this is all a very active, of course, research area, and becoming sort of increasingly compute intensive as the models we build become more and more sophisticated. So what are the technical challenges of infrastructure? So it leads to a whole set of challenges that we get for infrastructure for doing research in this area. Well, firstly, it's just scaling up. We need more and more data. Into our models, we want high resolution, both in spatial coverage and sort of and the granularity of scale, and we need more and more compute resources of those things. So just the pure scaling up becomes a significant problem. And then, as I said, the models become increasingly complex. We have a large amount of integration across models to capture all those independencies, and that could be integration across scales, from an individual item of equipment through a site or a building, through to an organization, through a region or a city, to a whole nation or a country, or even a larger region, a collection of nations. So we have to integrate all that between all those different scales and granularities, and then we want to be able to integrate across sectors as well, not only between the sectors of the infrastructure we're interested in, the water systems, the energy systems, the built environment, and the sort of transport systems, but also with those natural and human environments in which the research sets, so where we impact and take impacts from those environments. So we have a huge sort of integration problem, a problem of integration of exchange. We have to count with independencies, and this means we want to share data across models as well. So we need common standards for interchange and interoperation, common metadata standards. The whole system is becoming far more complicated, and we want to do that in a way that respects the ownership and security of various systems. So, and if we're looking at building digital twins, where we have these systems sort of monitored and operating in real time, that can add an extra layer of complexity on top, where we have real-time sensors, real-time input-output, and within the background, analyzing large amounts of historic data to provide predictive models. So this all leads us to a very challenging environment for research, and very often becoming beyond what an individual research group or department can manage. So what we're thinking, what we need in Daphne is a community hub. So we want a place for sharing and combining data and models together, where we can support the collaborations cross-institutional collaborations that are typically nowadays building and analysing these models. A place to deploy those applications, those data and models in a common place that those collaborations can share, and a place as a legacy. So a place where the data and models involved in modelling our systems can stay for a long time, beyond the lifetime of a project or a PhD thesis, where they may be available for long-term access and reuse in the future. So what we're trying to do in Daphne is provide that sort of that community hub. So what we have in Daphne is a hybrid high-performance computing platform to support the infrastructure research community, which provides a secure repository of data and models from right across infrastructure research and related areas of natural and human environments. And this provides us a collaborative platform to support the research and particularly develop multi-systems models of infrastructure systems, so we can link these different models together within one common managed environment, and also a place that we can then have a repository where we can make those data models available for the long term. So that's what we're trying to do in Daphne. So a little bit more about the project itself, what Daphne can offer. So Daphne, which is the data analytics facility for national infrastructure, it's what we're trying to build one of these platforms, such a platform. So it's part of the UCRIC program, the UK Collaboratorium for Research and Infrastructure in Cities, which both Edinburgh and Heriot-Watt are now members of. When Daphne was formed, though, there was actually 11 and then 12 universities. So our partner universities at the moment are the 12 partner universities of UCRIC and the partnership for Original Republic Universities of UCRIC, and the led by the University of Oxford. And we in STFC were asked to join as development and hosting partner. So we're at STFC, well, we are a research organisation, part of the research councils, and part of our mission is to supply research infrastructure, including computing infrastructure, to support UK research base. So we were approached as a place with long experience in building and hosting these kind of systems. So that's who we are, and we're hopefully this partnership that we have between 12 universities and STFC will lead to further partnerships across academia, government, and beyond into government and industry. Daphne is part of UCRIC, so I don't know how much people know about UCRIC, but there's two other parts. One part which is providing national infrastructure laboratories, other parts which are providing urban observatories. So Daphne kind of sit in the middle, where we can bring my data and models and simulations relating to both those components together in one common place. So in practice, we've done a lot more work, with the urban observatories at the moment than we have for the national infrastructure laboratories. So a bit more detail what we have in Daphne. So we do have a hardware platform, a dedicated HTC cluster, not vast, but nevertheless sort of increase on what a university department might typically have to support this particular type of research. In our machine room at Rose-Appleton Laboratory near Oxford. And so we have some sort of compute, but more significantly, that's set up as a Kubernetes cluster, and I'll explain a little bit about more what that gives us in a little while. So this gives us more computing power to scale up our applications. And then the bulk of what we've been doing on the Daphne development is building the software functionality on top of that hardware cluster. So this gives us a screenshot of some of the functions that we have in there at the moment. So we have login. Well, yeah, a login, but that's a proxy for having a user management environment where we have access control over the various assets, so people can control who has access to the data and models that are in the system. And then we also provide a data area where people can upload data and data sets and provide information about those data sets so they can share them with the groups they want to share them with. And that's organized into a data catalog. And then we have a support for models. So we have a support where models can be uploaded from a wide variety of groups, research groups, and in a sort of self-service way. And then users can then use those models to build workflows, to connect those models together, execute those models on our platform and provide results, and then visualization capabilities to give those, so we can present those results back to stakeholders. The visualization component is still under development. We hope that we're going to have a major release at the end of this month, but so I think Tom gives a little bit about visualization, but that's going to be changing fairly soon. So a little more detail about what some of those components are. We see Daphne is a sort of looking at the data first. We see data can support an information infrastructure with a data hub where we can share data together, integrate data together and provide data curation. We have a trusted, secure space to hold that as a data repository based around quite a rich, but we think quite usable metadata framework based on a standard called DCAT. And this gives us common search and access over the data sets. And we're going to give some demonstrations about that later. But Alex is going to give some demonstrations. And this forms a basis for integrating and combining data. And we want to extend this. One of the things we've been looking at is how to extend the semantic richness that we use to represent the data with an ontological framework around that data. And then this is just a couple of screenshots of what the NID, this database looks like. Alex will do more about this later. And then on the other half, the major component, which is we call the NIMS, the Modeling Large Infrastructure Modeling Service. This allows people to upload models into Daphne. And the point is we try to make it that more or less any models can be uploaded from anywhere. We use a method called containerization using a system called Docker, and this allows us to be very, very independent of the code and the operating system where the model was originally written in. And then those models can be uploaded in our system. We use this system called Kubernetes to orchestrate those different models together and execute them, and it allows us to scale up for more compute, access the data in the NID within the same security infrastructure, and access to visualization and access to the visualizations. So this gives us a repository of models to share. And then we can join these models together into workflows to chain models together, give more complex coupling of the models to give that systems of systems modeling that we want. Again, more about this in the demonstration later. So how is Daphne being used? Just to run through a small number of examples that we've been working on. To start with, well, a couple of relatively early examples we did in our development, mainly to show the scalability we can get with the system. So this on the left is a station demand model from the University of Southampton, where they looked at where you're putting a new railway station on a railway line, and looking at if you locate it in one particular place where people are likely to travel from to go to that station, to use that station. So you can look at where you might best optimize the location of a new station on a railway line. Using this, we got something about from changing from what they could do with executing sort of one model per day or something like that. We got that we could execute several models per hour, so it's quite a significant speed up on that. And the one on the right is an economic model using a system called Simim from the University of Leeds, looking at economic activity. Actually, in this particular example, on the area between Oxford and Cambridge, looking at with the changes of urban development, how that's going to affect economic activity. Another major use case we've been doing is working with a project that's been going for some years called the UK Infrastructure Transition Research Consortium, ITRC, led by the University of Oxford. again, we've built a system called Nismod, which is a pretty comprehensive systems of systems model combining a number of different models: transport, urban development, water, energy demand and supply, and waste, I think. Oh, and telecommunications too. And this has been used as Nismod has been used in the National Infrastructure Assessment, and that has now been brought onto Daphne, and the Nismod. ITOC and Nismod now see Daphne as the major sort of host for running Nismod into the future. We've also been involved in a relatively new project called OpenClim, led by the University of East Anglia, which is looking at the resilience of infrastructure and adaptation of infrastructure in response to climate change. I won't talk any more about this now because I'm actually got a section, a more detailed introduction to that a little bit later in the afternoon. And finally, one of our pilot champions, we had a number of champions from the university partners come onto the project to run particular examples. And Christian Jeans at the University of Sheffield used Daphne to sort of build a sort of initial prototype digital twin, linking up with the Urban Observatory in Sheffield, where they have a large number of sensors around the city, looking at traffic flow. Christian has built a real-time AI-based model to do sort of predictive, predictive model to work, estimate what the traffic is going to be like in 30 minutes time, which we put on the Daphne platform, and then took real-time, data from those sensors onto the Daphne platform to do that prediction in real time. And in theory, we could then pass the results back to Sheffield to control their traffic lights, but that what didn't happen. I don't think they'd let us do that at this stage. But nevertheless, it's a proof of principle that we can do digital twins on Daphne. So just a brief summary, kind of where we are. Daphne's been sort of under development for the last 4 years now. Done a lot of requirements gathering, a lot of design and implementation in that period. We've been doing a very intensive development over the last year and a half or so. For our final release, which is imminent. So it's coming around about now. We have a sort of final event later in the summer in July. And we've been spending a lot of time over the last year in particular, getting more and more pilot users onto the platform. We've had a number of champions, a lot of webinars like this one, and the hackathons. And we are open. So if people want to try out the platform, we're, while we're in the development phase, we're still very happy for people to come and try it out and see what they can do it. So if you are interested in using the Daphne platform, please contact us. Please contact us individually or contact us at this email address. And in the future, we are looking at our next sort of long-term sustainability. We are sort of talking with our funders at the moment about how we're going to manage that. And long term, we will foresee that we would be a part of the sort of national digital research infrastructure as one of our long term plan. And we're looking at future developments, particularly extending that support for digital twins, richer ontological and data model, richer machine learning, all sorts of things that we would like to do with the platform. I think that's it, just to summarize what we're having. So Daphne represents a sort of environment for research collaboration with a HTC platform to support research and technology transfer into sort of industry and government, with a data sharing environment with a common information infrastructure. So you can bring models on board, scale and couple them together and execute them, and a long-term legacy for keeping those models accessible for the long term. Still work to be done, particularly in digital twins, and the data management framework and ontology. But but nevertheless, we have what we think now is a usable platform. So yeah, that more or less summarizes what I want to say. So at that point, I think we will hand over to demonstrations to see how it works in practice.